Assalamu alaikum, dear students. Welcome back. Bismillahir Rahmanir Rahim. Today I'm basically presenting a very interesting example, that is almost asked in every interview. Okay, this question is personally asked from me in my public service commission interview. Okay, so this question is basically is about that let's say there is a man who is standing on a boat on the center of a boat, clear, and the boat weight is given, that is 3 pound per feet. Okay, and you see that the the man or the boat is in equilibrium. Okay, the question is that you need to draw the bending moment and shear force diagram for this question, or you can say for this boat. So one thing, you must ensure that the body or the man or the boat should be in equilibrium. Equilibrium means that summation of Fy will be equals to 0, means the downward forces and the upward forces and the downward forces must balance each other. So you can see that as the body is in equilibrium and the weight of the boat is 3 pound per feet, so first of all you need to draw. Okay, let's say this is the boat, and it is mentioned in the question that assume that the water exerts a uniform distributed load. Okay, the water exerting a uniform distributed load. Okay, that is uniform distributed load. Okay, now you must know that there is a weight of the boat which is given, that is 3 pound per feet. So obviously this weight of the beam is balancing by the same amount of the loading from the downward side. So the weight of the water, the pressure of the water which is uniformly distributed due to the weight of the boat is 3 pound per linear feet, clear. And similarly the weight of the boat is 3 pound per feet, clear. And now we need to find out the shear force and bending moment diagram now for the weight of this person, clear, because the weight of the boat is balanced by the upward forces of the water. Now you know that the weight of the person is given is 150 pound, clear. Now 150 pound is exerted on the boat, but the boat is uniformly distributed this load, clear. The boat is uniformly distributed the weight of the man, clear. Now therefore, to convert this point load to UDL, you need to divide this 150 pound by the length of the bolt, clear. So if you have an 150 pound load, okay, the weight of the bolt and the upward thrust of the water balancing each other, now the net loading which is developed of the water thrust is now, okay, that is this is the weight due to the this is the uniformly distributed load of the person, okay, which is 150 divided by this total length, that is 15. So if you divide this you will get 10. So this will be the uniformly distributed load of this person per foot. Okay, now the water, as the body is in equilibrium, the water will exert the same amount of pressure, you know, that will be the 10 pound per linear foot. Clear? And you apply basically 10 pound per linear foot. Clear? So basically you will see this kind of distribution, 3 pound and 3 pound and 150, and you know, so basically now due to this 10 pound per uniform distributed load is created, that is the pressure of water. Now if we don't assume that the load is uniformly distributed, the load is, let's say this is point load, okay, if it is point load, then what will be the shear force and bending moment diagram? Okay, now this is point load. Clear? Because if you assuming that the load is acting as in the shape of UDL, then the bending moment and shear force diagram comes out to be 0. Okay, so we need to consider the weight of the person or the man as a point load. Clear? So let's see how we will assign these loading in a SAP, and how we will draw the shear force and bending moment diagram in SAP. Clear? So let's see. We have a uniformly distributed load, okay, and the units are in pound and feet. Clear? So let's say pound feet, and there is also pound feet. Clear? Select. Okay, we have used uniformly distributed simply supported beam without one. Okay, the total span is 15 feet. Clear? And okay, now this is the beam. Make sure that you will be in axis plane. Okay, and there will be no supports. Clear? There will be no supports. Okay, this is the beam right now. First of all, we need to assign the UDL that is distributed. We need to make it 0, modify. Okay, and then unit should be checked, pound feet. This button should be checked, and forces, okay, in gravity, not in gravity. You have to apply the load in Z direction, because the load is from downward direction, in not in downward direction, the load is in upward direction. Okay, the uniformly distributed load, you can see that it is applied in from the upward direction, from the downward direction. Okay, from the downside to the upward direction. Clear? So therefore you will select Z, and as the Z direction is same to the load applied direction, so therefore you just need to exert 10 pound. Okay, clear? So the load is applied now from the bottom. Okay, assign the point load. Okay, make sure units are okay, add to existing forces. The load is in downward direction, so gravity is okay. Select absolute distances. At a distance 7.5 feet, you have a point load of 150 pound. Okay, so this is the load. So let's see, loads are assigned. Let's see, we will analyze the structure. Model do not run. Clear? Run now, and you save board. Okay, this is the bending moment diagram. The total movement is, you can say, let's see, we first of all check it, shear force and bending moment diagram. Shear force, so let's see, this is 75, this is 75, and this force is basically 281 pound maximum. Okay, so 75 pound and 75 shear force diagram is okay. And let's see the moment diagram. This is moment diagram, 281. Okay, 281. So this is also okay. So this is the procedure that in this kind of case, if anyone asks question from you, okay, that a person who is standing on a plane or a boat on the water, what will be the shear force and bending moment diagram? From one first observation, you can say that there will be the water pressure, and this the load of the man will be acting as in shape of a point load. So you can say that this load distribution will be somewhat like in this shape. Clear? Somewhat like in this shape. Clear? So this type of bending moment diagram will be will form. Okay, so this is the end of this lecture, and I hope you will learn a lot of. Okay, if you have any question, you can contact me, you can comments on my channel, that is Misbahullah Engineer. Okay, you can watch these videos and please give your suggestions. Thank you.